Welcome, my dear students. This is a continuation of electrophilic substitution reactions of aniline. Previous class we discussed about bromination in water, bromination with in the presence of acetic acid, then nitration with production. These two are happened, and the third one is sulfonation. In this case, the compound that is sulfuric acid is taken. So how do you write? This is aniline, NH2 is with sulfuric acid, just normal conditions are maintained. Sulfuric acid is an acid and aniline already we described as base. Acid base, a salt is formed immediately. So the salt is here taken, that is NH2 becomes NH3 and H2SO4 ionized as HSO4 minus, and H plus is taken by NH2. Therefore, this becomes plus and this is minus, and this is anilinium ion, and anilinium. H is named as hydrogen sulfate or bisulfate. This HSO4 can be named as bisulfate or hydrogen sulfate. At this stage, we are heating the mixture, that is 453 to 473 Kelvin. If you are heating the mixture, and here water molecule it loses. Water molecule is removed. Here H2 and here OH, and HSO4 becomes SO3 that attacks particularly at ortho para position. Why? Because NH2 is ortho and para directing group, electron donating ortho para directing group, activating the benzene ring. Therefore, the information here is benzene ring, NH2, and this OH and H removed as H2O. This is SO3. How is the name? SO3 benzene is sulfonic acid. Benzene sulfonic acid. NH2 with benzene ring is aniline. These two are mixed and design a new name, that is a sulfonilic acid. Sulfo group, sulfa. Aniline, sulfonilic acid. Yes. It is SO3H. Then this is in equilibrium. How? Very simple. This is an end which is basic in nature. This is another end with acidic in nature. It is ready to donate proton and it becomes SO3 minus, and it is a proton acceptor. It becomes NH3 plus. Therefore, the resulting one is like this. NH2 becomes NH3 plus, and SO3H becomes SO3 minus. Within the species, two oppositely charged ends are present. This is known as dipolar ion. This dipolar ion is known as Zwitter ion, which is very important term in our preparation. Zwitter ion. What is Zwitter ion? Simple information towards PU examination, that is dipolar ion. Within the species, two ends are present, negative end and positive end. Such one are known as Zwitter ions. And here sulfonic acid exists as Zwitter ion. Now observe the next reaction, Friedel-Crafts alkylation and Friedel-Crafts acylation. What is the catalyst here used? The catalyst used is AlCl3. Anhydrous aluminium chloride is the AlCl3, and it is interfered with aniline. Why? Because aniline, nitrogen has lone pair of electrons and AlCl3 is Lewis acid, and it is base. And what is possible? Electron pair of electrons on nitrogen donated to AlCl3 form a salt. That is, we have to write like this: NH2 plus AlCl3. A salt is produced, and what is the charge developed on nitrogen? As positive charge on nitrogen atom. As how does it influence the benzene ring? Donating electrons or attracting electrons to benzene ring from benzene ring. It is attracting electrons or withdrawing electrons away from benzene ring, so it is deactivating benzene ring. Negative charge on nitrogen atom deactivates benzene ring towards electrophilic substitution. So what is the final point? Aniline does not undergo Friedel-Crafts alkylation. Aniline does not perform or undergo Friedel-Crafts reaction. Why? Answer is here available. You just follow that one. That is the end of amines. After amines, as these aromatic amines undergo diazotization with NaNO2, H2O, and the final product is diazonium salt. That is, diazonium salt is a special topic, will be started very soon. The last topic under amines is diazonium salts. This already we discussed in the chemical properties of aniline. Aromatic primary amines undergo diazotization to give a salt that is known as diazonium salt, as it is discovered by John Peter Gase. Only for competitive purpose. General formula: aromatic ring is attached to N double bond N has positive charge and X minus. AR is aromatic ring. Next, N2 is N2 plus. N2 plus is diazo group, and X minus is, as we may use Cl minus, Br minus, bisulfate, and tetrafluoroborate. These are attached in the place of X minus. This is the general formula. And how to prepare diazonium salts. So next area is preparation. Very simple. Aromatic amines like aniline is treated with NaNO2 HCl, sodium nitrate and hydrochloric acid at 0 to 5 degrees centigrade. Then you will get this one. Now take one by one preparation. Aniline already we worked, but here this is a chance to recall. NH2 treated with a salt NaNO2, that is sodium nitrite with 2 moles of HCl produce, and you are maintaining 273 to 278 Kelvin temperature, 0 to 5 degrees centigrade, ice cold temperature, ice bath is maintaining. Then you got C6H5 and NH2 becomes N triple bond N and this nitrogen acquires positive charge, that is N2 plus group, which is known as diazo group, and Cl minus, and its name is benzene diazonium chloride. Other products are, as usual, NaCl, 2 NaCl, and 2 oxygens as 2H2O. Okay, it is balanced one. This you have to practice, and the entire reaction is known as diazotization. What is diazotization? Previously we described. So no worry that you have to recall from the previous case. This is a key equation and important for 2 marks in the final PU examination. Prepare as many times as possible and get command. Yes. Towards JEE or NEET orientation, how many moles of HCl used in this diazotation? Yes. Answer is 3 moles of HCl used in diazotization. But in the balanced equation, what is observed? In the balanced equation, only 2 are present, and what about the other one? The other one is nothing but to maintain or carrying out the reaction mixture in acid medium. So 1 mole of HCl, for what purpose? NaNO2, HCl produce an acid, HNO2, nitrous acid, and NaCl. Second mole here, an intermediate is formed, that is C6H5N double bond NOH is formed, that is mixed with HCl to form C6H5N2 plus Cl minus plus H2O. And third mole, this is second mole. Third mole, for what purpose? Third mole of HCl, keep reaction mixture in acid medium. Keep reaction mixture in acid medium. In acid medium. Right, we are coming to discuss about physical properties of diazonium salts. How are the physical properties? Very simple. Observe, they have no color and they are in solid state and they have close packing crystalline solids. So this is written as, these are colorless. This is an area less to explain, only factual information to be collected. These are colorless, crystalline solids. As being positive charge and negative charge, therefore as solids they are soluble in water. These are soluble in water. Why? Due to polarity being salts. Next, these are stable at low temperatures, 0 to 5 degrees centigrade is maintained. These are stable at low temperatures. That is why after preparation it should be immediately used. After preparation they should be used immediately. They should be used immediately. Next one is, what about BF4 species present in Diazonium group, that is C6H5N2BF4 is a salt, that is benzene diazonium, tetrafluoroborate, is a salt which is insoluble in water. This is the key point. Insoluble in water and stable at room temperature. Okay, that is the end of physical properties. Next, we will continue chemical properties of diazonium salt is a important area towards discussions.